Hey guys, so this is my walkthrough whoops, for ray diagrams and how we do ray diagrams and how we get them done correctly. Sorry, so I'm cleaning that up real quick. Okay, so we're going to go through the three different setups with ray diagrams. The first is going to be a converging lens, which means it's fatter in the middle and narrow on the edges, and we're going to see the light converge towards a point. The next lens we'll do is be a diverging lens, which has a negative focal length, narrow in the middle, wide on the edges. And then we're going to do a combination where we have a converging lens followed by a diverging lens. And we could do any type of lens combination and still follow the same rules. And so I've already pre-done all of my lines, so I'm just going to talk about going through and drawing each of these. The first thing, so this green arrow here is my object. And if I want to talk about its object distance, I would measure from this green over to the center of my lens. Okay, so if you're asked to do a ray diagram with an object distance of 12 centimeters, you need to measure from the center of your lens 12 centimeters over. Now, I'm using a focal length of positive 8 centimeters. So I'm using each of these marks as 1 centimeter. So this would be 1, 2, 3, 4, 5, 6, 7, 8 centimeters to the focal length on both sides. And then I've got 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So I'm using a 21 centimeter distance, or object distance, and an 8 centimeter focal length. So first thing I'm going to do is I'm going to draw a ray that goes from the tip of the arrow parallel to the axis, and will hit the lens right in the center of that lens. From there, that ray is going to be deflected or refracted to pass through the focal point. So you can see how it bends and goes through the far focal point. The next ray that I want to draw is a ray that goes from that same tip through the focal point, okay, and down to until it hits the center of the lens. Always wanting to make sure that I'm ending my line at the center of the lens. From there, it should come out parallel because it went through the focal point. It should now come through parallel. This computer doesn't want to move to that spot. Okay, it's real easy to fix though. I just force it, and then I got to make this thing as close to parallel to the axis as I can. That looks about right there. And then the last ray, to make sure that I get it to all line up right, should go from that tip of the arrow straight through the center. And if I've done it right, we have a spot right over here where all three rays come together. That would mean that if I drew an arrow, it's straight down like this, the arrow will be pointed just like all the rays come from the tip of the arrow, all the rays meet at the tip of the arrow. And this would be my image distance. This is where my image is. So first, it's upside down. It is smaller, and its image length is not as big as the object length was. Now I'm going to grab my calculator real quick, just so we can kind of show. The object distance was 21. If you remember that formula, it's 1 over do plus 1 over di equals 1 over f. And so I'm going to take 1 over f minus 1 over do, so it's 1 over 8 minus 1 over, I said we were at 21 if I remember that right. Now that will equal 1 over the image distance. So I'm going to invert that, okay, flip it upside down. I get about 12.9, or about 13. Well, if this f is at 8, I would count 9, 10, 11, 12, 13. I mean, I'm pretty dang spot on considering that I'm using a computer to draw them. Now, hopefully they're parallel, and that's why we get to where we are. But that's a pretty neat deal that we can show that it really works. It is upside down, and we could figure out its magnification. All right, let's go ahead and talk about our diverging lens. Some of the same rules are going to apply. For instance, the first ray I'm going to draw is my parallel ray. It's going to go parallel off the tip of the arrow. By the way, the focal length is -8 is what I'm using. So again, focal distances are 8, and my ray out here would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 more than 8, so again I'm at 21. So I've still got a 21 object length or object distance. Now this is where it gets a little tricky. I'm supposed to bend, to the focal point. Because this is a diverging lens, instead of bending towards the far focus, it's going to bend away from the near focus. So if I'm doing this right, okay, this ray will come right in here, roughly speaking. It's pretty close. And if I were to backtrack it, we'll leave that alone for now. Okay, so that, I better do it now. If I were to backtrack that ray, okay, it would come straight through the focal point. Let me see if I can get this to line up right. Right through the focal point, okay? And that's what we're actually headed for. We're wanting to get these to line up and go on that straight line as if it's the same line. So the actual ray of light will deflect upward, okay? But it will appear as if it's coming from this focal point back here. If I want to know what line is it on, it'll appear from there. The next ray that we typically draw goes through a focal point. Instead of coming through this near focal point, though, it's going to be aiming for the far focal point. Okay, so if you can imagine, okay, it's shooting to hit this second focal point. But when it hits the lens, it's going to be deflected. And the deflection that it receives will be a parallel deflection. When we go focal point, it comes out parallel. So it's headed towards the focal point, but when it hits the lens, it's going to deflect out parallel. So this black line right here never actually occurs. That's just where it's trying to go. And if we follow that, remember our eye's over here on the right. If we follow the light back to figure out where in the heck does the light seem to be coming from, okay, you could follow that back with this green arrow. So these green lines are where the light appears to be coming from. And the last ray is always the central ray. We go straight through the center of the lens, and if we do that right here, there should be a spot where it looks like all the lines are intersecting. And so I could once again draw my ray upright this time. My little arrow is upright, but it is smaller, but it's close to me. And so I would say if I looked at an object through that diverging lens, wow, that object's close, but it's tiny. Like, what happened to it? Why is it so small? But it is upright. And if we did the same calculation here, we do 1 over the focal length. But remember, the focal length is negative because it's diverging. So 1 divided by, clear that. Sorry, we'll go 1 divided by negative 8 minus the object distance, which is 1 over 21. We get a negative 0.17, and if we invert that, it comes out to be about negative 5.7 or 5.8, almost negative 6. Well, if the focal length is negative 8, I'm at 5 I'm almost to 6. So again, we did a good job of measuring that and finding that on our grid. So diverging images are typically going to be virtual. They're going to be on the same side of the lens as the original light source, the object. All right, so now let's talk about our last one. Last one is when we have multiple lenses in combination. The same rules are going to apply for our first, get rid of that. Same rules are going to apply for our first lens that we had before. This is a converging lens, so I'm just going to walk through those normal steps. I know I'm going there, and then my second one goes there. I draw my line through the near focal point, comes out parallel, and ray number 3 is right there. So now I can bring my object. So my object produces an image right here where the blue arrow is. It's upside down. It is a little bit smaller. This image, okay, from the first lens is going to be the object for our second lens. So we're going to let all the light that joined here spread back out as it goes through the second lens, and we're going to watch and see what happens. So for instance, first ray is our parallel ray. These lines don't want to behave. All right, well, we'll just come right in here and we'll just force it. I'm going to start right out there. Let me come back right here. Do the best we can to be parallel there. So there's my parallel ray. But when it, oh, I'm doing the wrong one. That's why I'm having a problem. Okay, but when I get to, I'm going to have to use the purple. Hold on. Scratch that. Let's use the purple one. All right, let's try that again. Sorry, guys. Sometimes technology is our friend, and sometimes it's a dingbat. All right. So we come through, come out nice and parallel, right about there. And when we hit that spot, we're going to deflect, okay, as if we were coming from this focal point here, the near focal point. I think that's this one. Yep. So you guys can see how the light wants to go off to the right, but where did it appear to come from? We're going to follow that pink line backwards. So again, this light on the left of the lens is not really there, this pink line, but it's where it appears to be coming from. The next one would be the one that's aiming for the far focal point. Do it again. All right. So this guy is aiming for this far focal point. That's what it's shooting for. But it's never really going to get there, because as soon as it hits the center of the lens, it's going to get deflected backwards. I need to pull this up just a little bit. And pull this up just a little bit. All right. All right, so right about there. As soon as it hits that lens, it's going to come out parallel, so it'll never actually hit this focal point. And then the last ray is the ray that goes through the center. And if we look right there, there's a central point when they all meet. And we come down and we draw our little arrow in the right spot. It's a little big. My arrow's a little big, but that's where our final image would be. It's the image of our second lens. The image of our first lens becomes the object for the second lens, so it's a carried on process. But these same three rays are drawn over and over again, whether we're doing converging or diverging lenses. You just need to understand the rule, the difference between these two lenses and whether they converge or diverge. There are going to be special circumstances when we bring the object inside the focal length. Some very cool stuff happens when we do that. And so we may go over that. I think we'll go over that in class, but if you aren't in class today, we do ray diagrams, you'll want to talk to me individually or come to me after you've watched this video and let me know. All right, guys, good luck, and we'll see you in class.